Okay, so we know this would be the Riemann sum f of ci times delta x I. Okay, this is the Riemann sum, which is the approximation to the area between the curve and the x-axis. And we know how to get the exact area, which is we let n, the number of the subintervals, approaches infinity. So we take the limit n approaches infinity for the sum. Then this would be the exact area, right? And we give a name, we denote this limit by this symbol, which is the integral from a to b of f x dx. And this f is the same f here. Here is ci, here is x. The delta x we know, which is the change in the x values. And this is the small change, right? When n approaches infinity, and this delta xi would be very small, which we use the dx to denote it. And this is the integral sign. This integral sign is actually here is the sum, right? Is the sum here. And this is the interval from a to b. So this is called the definite integral. Integral of the function f of x of the function f from a to b. Here a is called the lower limit of the integration, and b is called upper limit of the integration. So now let's look at some remarks for this definition. The first one, if the function curve is above x-axis, then the integral from a to b from the integral that this is from the definite integral, this one is actually the area between the curve and the x-axis from a to b. This is the area if this function is above x-axis. 2. If the function is below x-axis, right? So currently we didn't have any examples below f(x), but it exists, right? We always have some function below x-axis. That means f values is negative. And what is this one represent? This integral represent? We notice that if we know this integral is the Riemann, the limit of the Riemann sum, the Riemann sum is we divide this one into several intervals, right? Do the calculation for the rectangles, right? But when you do the calculation, you get the height. The height actually here, the height, this height actually have the f of ci, right? F of ci, which is a negative number. So this area is negative. So if you add them up, you have negative area. So this is the equal to the negative area of this region, right? So this gives you an idea of the third remark, which is called the signed area. The signed area tells you that the integral from a to b dx, which is the sum of signed area. Okay, what does this mean? So let's look at this example. We have this curve a and b, and for this region, this region is negative, right? Which is negative. If you do the calculation for the integral, this region is below x-axis. So the area is positive, but I give the name which is the negative. If we do the integration from a to this point, this will be a negative number. So we call this the negative area. And for this region, which is above x-axis, so this is called the positive area. So what is the integral from a to b, which is the positive area plus the negative area? Okay, so now let's look at an example. We want to compute from -1 to 2 of x dx. Okay, so here you compare the integral notation. Okay, I write here, this is the integral notation. This is a b f of x dx. This is the integral notation. So here a is equal to -1, b equals 2, and f of x equals x, right? So we can draw the graph for f of x equals x. This is the one, f of x equals x. Okay, so the region is from -1, this is -1, this is the 1 and the 2. So actually this integral is to ask you to find the signed area for the shaded region, the sum of the signed area for the shaded region. Okay, so let's look at how to do it. Use the geometry. And here is 2. So here is also 2, right? Because so this area is 2 times 2, right? The height times the base times 1/2, right? Which is equal to 2. So here is 2 units. And this is the positive, right? And for this region, here is the area, which is height is 1, right? 1 times the base is also 1. The base is also 1 times 1/2, so which is equal to 1/2. So the area is 1/2, but the curve is below x-axis, so we give a sign which is called the -1/2 area. So the integral from -1 to 2 of x dx, which is equal to the positive area plus the negative area, which is equal to 2 minus 1/2, 3/2.